Hello, welcome to the Science for Policy podcast. My name's Toby, and today I'm joined by Noam Obermeister. Noam recently completed a PhD on the learning journeys of science advisors in the UK. He currently works for the Centre for Systems Solutions, where he helps to design and deliver policy simulations and so-called serious games on sustainability issues. So, Noam, welcome to the podcast.
Hi, Toby. Thanks for having me.
So just to put this in context, when I say you recently completed your PhD, I mean like really recently.
Yes, basically had my Viva last week.
How did it go?
Very well, thank you. Yeah, very well.
I remember being terrified going into mine and then about halfway through thinking, I guess I'm quite enjoying this.
Yeah, it is. It's one of the rare chances you'll have to talk about your, 3 or 4 years of research and your PhD. So I think you got to go into it with a positive attitude.
Yeah, and perhaps the only chance you'll ever get to sit down with 2 or 3 people who've all read your work from start to finish.
Very unusual, unless of course, in the continental European model, you're presenting to a public kind of open presentation that has its own kind of worms and anxiety associated with it, I guess.
Yeah, I mean, I'm sure that's true. Although I don't know how many people in the audience there would have read your work either.
Probably, yeah.
All right, well, I don't want to repeat the Viva experience all over again by any means, but we are here to talk about your research, so let's do it. You were studying the learning journeys of science advisors. What does that mean?
So there were a few angles, but I guess I should start by saying what was the objective of this research. I wanted to understand how and what do science advisors learn in their mostly experience. You don't get much from a textbook or from a kind of teaching or PowerPoint presentation. It's very experiential, very, to use a jargon word, tacit. To my knowledge, no one had tried to look at that empirically, dig deeper into, what's going on, how it varies across contexts, how it differs between, for example, what kind of disciplinary training you've had as well. So those kinds of questions drove the research. In terms of what I did, I mostly interviews, kind of long form interviews, 45 minutes plus, with some very experienced advisors, some of them, for example, former chief scientific advisors in the UK. But I also did a couple of other things. I looked at 3 advisory bodies, 2 kind of more traditional committees, and one network organization in Cambridge, Centre for Science and Policy. So that was more ethnography. I was doing observations of meetings to kind of see the action side of science advice, not just the stories that people were telling me.
Mm-hmm. And these bodies were advising who?
The British government, for the most part. There's also arm's length bodies, and then the final thing was more experimental, and that was a few diaries. In the UK, they have this scheme of policy internships. So if you're a PhD student, you can get extended funding to go work into a government department for a few months, and that's obviously a great learning opportunity. And so these people would fill in diaries of their experience, like a personal diary, kind of. So I looked at that, and then finally a simulation, essentially a fake fictional advisory committee with some early career researchers. So that's the full methodological kind of landscape. Yeah.
Okay, and you mentioned a minute ago something about this fictitious science advice committee that you created. Could you say a bit more about that?
Yeah, so because, if learning is experiential, and that's the premise, then you want to recreate a kind of advisory setting and then observe, this sounds terrible, like lab rats a bit, but observe then what's happening in the room when you simulate an advisory setting. So I had that in mind. And then I ended up working with this student society in Cambridge. They're called the Cambridge University Science and Policy Exchange. And we decided, okay, let's host and co-run a kind of simulation of a small advisory committee, technical advisory committee, and the Department for Environment, Food and Rural Affairs, so the Environment Department in the UK, has this high-level advisory committee, the Science Advisory Council, and basically I was observing this DEFRA SAC, as they call themselves, and I was using kind of those observations to emulate the chairing style and so on, recreating as much as possible a kind of in vitro advisory committee setting. And that worked really well. We had a debrief, we had a chat, and what people said after an hour of this fake fictional committee setting was basically echoing to a great degree what I was hearing from these people with 20 years of experience in the field.
Okay, well, so I want to ask, because you mentioned that you were observing this SAC, right?
Right.
Delightful acronym, so Science Advice Committee. And you were then recreating what you observed, or trying to, in your lab with the lab rats. The question that springs to mind is, why bother? I mean, if you already have access to the real thing, why bother then to try and recreate it?
Yeah, so in theory, what you say makes absolute sense. In practice, what you find, or what I found, is that when you're observing these meetings, it's basically incredibly difficult to learn anything about learning. You can't see what's happening in people's heads, whereas if you have a more controlled environment where you're designing the topic, you're designing the process, and then you can talk to people in a very kind of heart-to-heart, it's much easier to extract data, essentially. Yeah.
Okay, so you have experimental control, essentially.
Yeah. The downside, of course, is that because you control the process, the question then of validity comes up. Well, are you not basically creating these lessons through the design, right? So, double-edged sword, as always.
Yeah, indeed. I mean, I can see why that's a worry. But I guess it's also somewhat reassuring if the outcomes you see in your lab are similar to the outcomes you observe in real life. Okay, you must be doing something right.
Yeah, I would tend to agree, but I'm sure I could. There would be some valid objections to that as well.
Yeah, I'm sure. But this is not your Viva, as we discussed. So let's leave that kind of worry to your examiners. So It sounds like you are interested in the process of learning, how a science advisor is made over time. So what's the answer? How is a science advisor made?
I'm still struggling with the question of whether advisors are born or made, right? So the kind of the nature versus nurture issue, and that sort of structured the way I approach this. And obviously they are made to the extent that there are professional norms of conduct, there are modes of giving science advice, and these elements are kind of, well, I describe them nearly as cultural, basically. They're like a professional culture. They exist in this strange bridge world between kind of academic research and the business of government or civil service, and you learn to navigate that. You learn to become proficient within that space, to do things that don't upset people, to say the right kinds of things, to act a certain way. So in that sense, like any social conditioning, you're very much made. But in another sense, there is also a kind of quality, or rather qualities, that make you a kind of more effective or more acceptable advisor. Not all scientists are kind of made out to, or have the right kind of skill sets or tools to do this. I mean, it's really challenging. It's a very hard space. And, for example, you have to be extremely perseverant. You can't expect a kind of also linear impact. If you go into this and you expect that your research is just going to translate into policy, you're going to be quickly disappointed. So long story short, there is parts of the equation that are about what kind of person you are, what kind of character traits, personality traits that you have. And another part, of course, which is, about the environments you're working in, the institutions, the professional culture, and even the national culture,
Yeah, interesting. I have talked a bit on this podcast fairly recently with other people who've also worked on this area of the skills, the competencies that you need to be a good science advisor or to work well in the science advice context. And those seem to have been, Well, okay, first I should say there seems to be lots of overlap, lots of agreement with what you're saying, which is good. But then those seem to have been largely framed as, okay, hello, you're a scientist and now you have a chance to interact with a policymaker in such and such a situation. So what skills and traits do you need? And I wonder if I'm right to infer that your work is focusing more on actual professional advisors, people who end up swimming largely in the policy pond, as it were, rather than, being scientists sitting in their lab and occasionally picking up the phone to help out. Is that fair?
I think that's fair. I think, part of this was, of course, from a researcher's perspective, was kind of sampling issues. How do I choose the population I'm talking to? I excluded government scientists. I mean, government scientists are a huge part of science advice. For various reasons related to research design, I didn't talk to scientists within government organizations who are also very much advisors. I didn't talk to many people who've had public engagement, informal engagement, and my findings or the competences, the skills, they are coming from a professionalized, more or less kind of, role of science advice in a more formal capacity, perhaps.
Yeah. Okay, but it seems like some of the facets that you mentioned are less like professional skills to help an advisor do their job well, and more about, I don't know, ways to survive as an individual so that you don't drown or get eaten up in the shark tank. I mean, I'm sure you don't put it quite as provocatively as that, but you see what I mean? Skills are one thing, but these traits like resilience and confidence and so on, those seem a bit different.
Yeah, so in fact, I make a distinction between skill sets and character traits. Skill sets, I don't think we need to talk about them because they're fairly well known. They are research skills, communication skills, what I would call political acumen or political flair, a mix of hard and soft skills. They are, how well do you do, how well do you review a document? How well do you synthesize the evidence base? And I mean, this has been talked about more times than we could probably count, either in the field and on this podcast. But the character traits, I mean, I personally see three important ones. One is adaptability, the other one is empathic listening, and the third one would be self-assurance. And they all relate to learning in different ways. So adaptability, very important that adaptability is not flexibility, because scientists would be very reluctant to accept that, for example, they would compromise their integrity or their rigor. So if you sort of, the connotations with the word flexible, it doesn't quite work, right? So adaptability is more about being able to be a chameleon within certain contexts, being able to basically adapt to different cultural norms, so different professional cultures. And there is an idea in sociology, of cross-cultural adaptation. And so the idea is that you kind of, what's your propensity to understand, accept, respect different cultural norms? And that's kind of where adaptability is coming in here. Adaptability is also about being open to new opportunities. You shouldn't expect that there is a career track, a kind of defined career track for becoming a science advisor, if you will. So all of these people have kind of dipped into different things. They're very multidisciplinary. Yeah, and they've dipped into various areas, and that also gives them the kind of strength and edge and big picture view that they need in this space. So that's one, right? I could talk about it for ages. I'll try to move on. But the second one's much more intuitive, empathic listening. It's just a combination of, being able to listen, ask good questions, but also with an element of empathy, understanding policymakers' constraints, understanding the pressures they're under, and basically being able to demonstrate empathy, because it's not just about doing it in your head. You also have to kind of personality-wise, you have to show that you're understanding, you show that you're listening, and so on. So that's a really important trait for building trust, and I'm sure you've heard that from many. And the last one, in some ways, is kind of the most interesting one is self-assurance. And, self-assurance is not just confidence in your ability, right? It's not just an ego trip of like, I've got the best, results. Let me tell you about it. That's not going to work. It's also confidence in being able to articulate the limits of your advice. It's confidence in the uncertainties that you're articulating. It's also confidence in the system. And can't stress this enough. If you don't trust that science advisory systems or ecosystems work, then how can you build true kind of self-assurance or confidence in one's ability to kind of influence that system or one's ability to contribute to science advisory processes? And this one connects to experience. The other two, it can be sort of your personality. You can be you can come into it very young, very unexperienced, and you can be very good at adaptability, very good at empathic listening. But self-assurance kind of involves that building experience over time. So that was one of the findings, of talking to these very experienced advisors, that they said, you can't go into this at a high level without building that experience up. So, yeah.
Yeah, great. I mean, actually, I know we talked about this a few minutes ago, but it's still not quite clear to me how much you're saying we can learn these skills and how much you just have to be born with them.
Yeah, so there is a sense of kind of having these predispositions. You can, of course, also develop them, right? You can work on these aspects. I would say you can work on your strengths. You don't have to combine all three. You don't have to be a pro at all three. But if you know that, for example, you're quite good at working with various stakeholders, you're quite good at kind of talking to different audiences, then maybe you can make a more conscious effort to kind of become the person in the room who does that. Remembering that sometimes it's presented that way in the UK with the kind of government chief scientific advisor. It's not a individual sport. It's more of a kind of team effort, right? So not everyone has to be the best at all skills or all traits or whatever. Yeah.
There seems to be a common theme here, at least with some of these, because you emphasize with adaptability that it's not about compromising yourself. You said it's not about flexibility, like becoming a political animal rather than a scientific animal, if that's a phrase. It's just about being able to survive in these contexts.
Yeah.
And that's also the case with empathic listening, right? Because empathy means understanding someone else's viewpoint and, empathizing with them without necessarily agreeing or giving in. So is that a common theme? I guess I want to ask, to what extent does a scientist need to change themselves to become different, to become a science advisor? Or is it just about being able to fit in an environment with others who are different from you?
I guess that relates to, again, whether or not your existing skill set, personality fits within the paradigm. And that connects to, and we haven't talked about it, it connects to one of the two theories that I was looking at in particular, which is the idea of transformative learning. The hypothesis goes as follows, that the more disorienting a situation is, the more it doesn't fit within your existing worldview, within your existing kind of frames of understanding, the more likely it is to have a transformative effect. So, there's kind of a decision tree. One is you critically reflect, and I'm, just broadly summarizing Jack Mesereau's, very comprehensive work. But one is you kind of have this disorienting dilemma that he calls, and then you kind of, you go one direction, which is, okay, I'm going to critically reflect consciously on what happened. How do I adjust my understanding? And this is more subconscious, right? How do I adjust my understanding to fit this within the kind of my own narrative, my own worldview? And that's one thing. And the other is to ignore it and say, well, they're all a bunch of idiots and, I know better or something, in the situation. So you have a kind of, somewhat conscious decision tree. And I talk about culture shock because I present kind of policy and science, or academia and civil service, as kind of two distinct professional cultures. And the levels of culture shock will depend on how at ease you are in the situation working with policy colleagues, and or how much kind of transgression of the norms that you're used to. So, for example, the norms of rigor, giving numbers to uncertainty, for example, and so on. How much of a transgression of that do you have to make? And then how uncomfortable does that make you feel? And then by virtue of that, how much are you willing to change? So it's difficult to box it all in one short speech that I'm giving. But yeah, that would be the idea of transformation in a nutshell. So you only have to change as much as you're willing to change. And by the way, changing and being inauthentic, for example, I don't think gets you very far. But I haven't tested that empirically. So,
except that we all test that empirically in our daily lives, maybe.
I suppose, but to answer your question, that if you really believe in the importance, if you're not a cynical scientist, or you really believe in, I don't know, the importance of providing a nuanced picture of a discipline or an evidence base around a topic, that there's only so much that you're willing to compromise on. And another point is, if you want to retain trust from colleagues, from scientists, you can only go so far, right?
Yes, that makes sense. So then here is the obligatory question about the immediate practical uses of your research. Does all this mean that you could take a scientist and, I don't know, give them an interview or observe them for a few days or test them in some way, and then figure out whether they have these traits and therefore whether they would sink or swim in a policy context? Can you spot a good or bad science advisor at 20 paces, in other words?
So I think it can be done for sinking. I don't know if it can be done for swimming.
Okay, go on.
And so what I mean is, if you are literally the opposite of, if you combine the opposite of all three character traits I talk about and many more, then you could put quite a high probability that you're going to sink. So, it's a bit of a half answer, I'm afraid. And I, of course, I'm reluctant to say that, you could do a survey and some sort of dystopian science fiction of science advice where you can classify people into competent and incompetent advisors or something. Yeah, if you essentially have the opposite of all of the things that are valued in this space and important to both sides of the boundary, or to both cultures, or whatever you want to call it, then you're not going to get very far. And that we can probably predict. But the opposite, I'm not sure. Yeah.
So you might have all those skills and it still might not work out for you.
Oh, yeah,
right?
Definitely.
Yeah, I guess there's a role for luck then, I guess as in any career, you might be the ideal candidate and just not get your lucky break.
Incredible amounts of luck. I mean, that was mentioned by, most of my interviews said things along the lines of, I've been so lucky, or have described moments of kind of serendipity and just being in the right place at the right time. But unfortunately for advisors, it's not just about luck in terms of, getting yourself into good situations or the right positions. It's also impact. I mean, the amount of luck involved in impact is ridiculous. You might write a report and then you're kind of 2 months too late by the time that it's published and the government's already moved on. So the sheer luck involved in science advice is quite disheartening, especially for unexperienced advisors.
One more question on these character traits. So we're talking about the traits that you think you need for scientists to become advisors. How big a leap is this for a scientist? I mean, to what extent are these traits that we're likely not to find anyway among researchers? And I ask because I feel like things like adaptability and empathy are going to be pretty handy in research careers too.
Yeah, that's a good question. I think if you want to be liked by fellow, if you want to be liked by fellow scientists, researchers, I think it's good to have these three. I mean, they sound very positive, so, that I could see that. I'm not sure they are necessary. I mean, there are plenty of extremely effective researchers who, you could qualify as kind of rather rigid. Plenty of PhD students and early career researchers suffering from imposter syndrome, but they're still great researchers. and also some great talkers and not very good listeners in science as well. So I can see how they would make you a more likable principal investigator or head of a lab or something, but they're not necessary for success. Not as much, I think.
Right. There are the niches in research where you can get away without those, but maybe there aren't those niches to hide in the policy world, is what you're saying.
That would be my hunch. Yeah.
Yeah, very good.
Yeah.
Okay, moving on. You use a little metaphor in some of your writing, which I hadn't encountered before. You talk about the T-shaped science advisor, as in the letter T. What does that mean?
I attribute this directly to a couple of quotes what people told me. I hadn't come across this before, but it's the kind of career metaphor that it's been around for a while, that you have to have subject matter expertise, but also be able to work across a variety of environments. And so in a science advisory context, what that means is that you do need some depth knowledge. You need to have done your PhD, postdoc years, whatever it takes to kind of develop that subject matter expertise. But really importantly, you need to be able to work across disciplines with other disciplines, but also with other stakeholders, with non-experts, non-specialists, and of course policy colleagues and so on. So this T-shape is quite interesting because actually it makes a case against generalism. It makes a case against becoming a jack of all trades and master of none. And in the British civil service, the kind of professional culture there is that you're moving around all the time. And in fact, in a strange way, the holy grail of a civil servant is the generalism, is to know a little bit about everything. And the science advisor in that context, and I think this is really important to scientists, you can talk to different people. Yes, you can collaborate with various experts and non-experts, but you need to be able to talk about your depth expertise, your that skill set too.
Okay, so it's the letter T like an uppercase T. The vertical bar is the research depth,
exactly,
and the horizontal bar is the
I should have started with that. Yeah, thank you.
Yeah, no. I think it's probably clear. I mean, it's certainly clear when you see it written down. I'm just aware that people might be hearing it only. Well, then I can absolutely see why the vertical part, the depth of research, is important if you're advising on your subject. If you're a volcanologist, and one day you're called in to advise on volcanic activity. So absolutely, you need a deep grounding in your own field, and also the horizontal part, the skills of how to understand and communicate with people in other fields. But isn't that more the unusual case? I mean, more often than not, especially in the UK, where we have, chief scientific advisors, it's only going to come up quite rarely that your specific scientific niche is going to be just what's needed. More of what you'll be doing is the stuff we've talked about, where you collect and synthesize from a wide range of areas. So then why is the depth part relevant? Why be T-shaped if most of the vertical bar of your letter T is never going to come up?
I think the point that my interviewees were making was not about the kind of very rare occasions where you can talk about the very specific part of molecular biology that you're working on, right? But instead, all the kind of other stuff that comes with becoming a specialist. The more you know, the less you know, the kind of rigor that you develop in a particular field, the level of socialization, that's really important. So like the level of kind of, in your personal identity, the level of science, of understanding the scientific system, understanding the publishing world, and whatever it is that kind of is happening there, understanding scientific collaboration. And for these interviewees, for these experienced advisors, they see it as a very important part of your journey to do all of that. They told me literally, you got to do the science for a bit before you can take the kind of bird's eye view. Part of me actually doesn't know why. I couldn't tell you exactly why that's the case, but it seems to be they were actually very anxious or concerned about a trend of people going straight into the big picture view. Who knows? Maybe it's because that's also a kind of model for consultants, and within the science world, perhaps there's a kind of reluctance to go down the consultancy route, I guess it's also what makes you stand out, right? To be the subject matter expert. It's what kind of confers you the authority or the hat of the specialist. So it's all of those things, I think, combined.
And these interviewees were speaking from their own experience. They were saying, look, I'm glad that I had this particular research depth because it was valuable to me.
Absolutely, absolutely. Even the most interdisciplinary social scientist I spoke to, who had dipped into, huge amounts of research projects and various fields, kind of like moving between areas their whole career. They still insisted that, even if your subject matter expertise is a process, for example, designing a citizen assembly or something, that matters. And they were insisting that you need that subject matter expertise. So there seems to be something there. I couldn't quite tell you what, maybe, some of the listeners maybe will have their own idea.
Yeah, maybe so. There are a couple of other areas of your work that caught my eye that I wanted to ask you about, if I may. The first one is you have two very nice diagrams, which I perhaps won't try to describe in words, but I'll link in the show notes, showing the difference between two different kinds of intelligence, what you call collective intelligence versus networked intelligence. I mean, you basically have like differently arranged squiggly lines collecting different. This is why I shouldn't try to describe them, I guess. You can do a better job than me, I'm sure, of explaining the difference between these two kinds of intelligence and what does it have to do with science advisors learning?
Yeah, so I should start with a qualification that I know that recently Jeff Mulgan was on the podcast, and his understanding of collective intelligence is going to be very different from mine.
Meaning you disagree with him? Or it's just a different use
Just
of the
a
word?
different, actually, I'm trying to redefine something that's probably more ubiquitous than my understanding. But the collective intelligence nowadays is being used very much in terms of the kind of combining people, groups of people and technology, and kind of coming up with creative solutions with the use of technology. So that's the definition that Jeff is working with, and Nesta and so on. But what I'm getting at is slightly different, which is the kind of more, I don't know, sociological aspects of that the whole is greater than the sum of its parts. That's kind of what I'm getting at. That when you put a group of people together, when they have high quality deliberations, when there is a certain diversity of views being deliberated in the room, then the product of those deliberations, in a way, they can't be reduced to the parts. So really, like, in a science advisory context, what that means is that you generally find this model in committee settings, and the knowledge products, the reports or letters or whatever it is, or even conferences that come out of these settings are never prescribed or predetermined. They're emergent. And this is really important because some of the best, and this is not from me, but from broader literature on this, some of the best reports, the most kind of avant-garde, resilient and impactful, actually never had an outline. They never had a kind of strategy. They're emergent. They come out of a collective position, sometimes a compromise, sometimes a consensus. And one other important thing about this is that, of course, when you have high quality deliberations and you have a diversity of perspective, disciplinary perspectives and so on around the table, you're obviously going to learn more, right? There's mutual learning in the process of formulating a collective position. So what's really important in this collective intelligence model is to have open-minded and trusting sponsors, as well as inclusive leadership. So your committee chairs, your chief scientific advisors, basically the leaders, they really have to make sure that all the voices are included, that everyone has a platform to express themselves. Then the other end is the networked intelligence model, and this is the address book approach to science advice. This is where policymakers have their kind of go-to people or institutions. They can be contained within institutional networks, or indeed they could literally be the address book of an individual civil servant. That's also a network. So this is the idea that you have institutions, people, networks that you know of that you can tap into. And within those networks, you can talk to the kind of individual nodes of the networks. So this would be like a very different form of advising, right, than a committee setting where you're kind of deliberating in a sort of quite an independent, quite an arm's length space and coming up with specific recommendations, specific outputs. Why is it important to make that distinction? Well, because in this case, it's much more ad hoc. It's more individualized. Influence has to do with trust, the trust of the individual expert. It has to do with, framing your arguments with conviction, political clout, and so on. And so actually, I've personally observed in my research, right, that advisors are much more like kind of advocates, or as maybe Roger Pilkey would say, stealth advocates sometimes, in these networked settings. So there are many ramifications in terms of learning, behavior, and also, knowing where you are is important. Knowing that you're in this mode of advice versus the other is sort of, I think an important thing, so that you don't act perhaps in the way that you might in one model in the other. So of course, these are completely made up models, right? They don't fit in every context and so on. But at least I think, hopefully, they represent two very distinct modes of advising and the kind of various consequences and implications of either.
So the distinction I think is very interesting, but it sounds like you're not making a recommendation. You're not saying one model is better than the other.
No, because it depends on the context. For example, one is very cheap and very fast. The networked intelligence model is kind of easy to deploy or much easier to navigate. The other one's slower, more costly, and so on. It really depends on what you're trying to achieve. I mean, if we had a scientific advisory system that only depended on fast communication between scientists and policymakers in a networked model, I think scientists would be quite upset. I mean, we'd never have the good horizon scanning. We wouldn't have reports that bring together important bodies of evidence. I mean, Sapea's whole model, right, would be completely different as well. So, of course, you can combine both as an organization, but your strategy, your kind of unique selling point or, unique proposition is always going to be more or less in one of these two categories with, overlap sometimes and so on. So it can be useful, hopefully, as well from a strategic point of view.
All right, makes sense. One last question for you to kind of sum it all up. I suppose it's clear how your research can be very useful for people who work in science advice or aspire to, and maybe also to help us design science advice institutions, taking these things into account. But you also make a comment in your conclusions that you think these things can inform the design of policy for science. And that surprised me a bit. How do you mean?
Yeah, so here the argument is that, in a way, science advisors have, in some ways, kind of the best people to ask about impact metrics, the kind of impact agenda, as it's been called, and, how on earth does one translate or communicate research into the policy arena? Of course, there are many aspects to impact. You can also do public engagement and, science communication. There's actual research impact. There's translating into marketable products, and there's plenty of stuff. But the policy arena, science advisors combine a very good understanding of how research works, and by the way, lots of them also have managerial roles, the very experienced one, within research. So they don't just have the kind of doing the research bit, they also have the managing the research knowledge. And with the doing the research, the managing the research, and the advising the policymakers, they have this unique combination of tacit knowledge about understanding, what is a realistic assessment perhaps, or realistic metrics or realistic evaluation of how research can feed into policymaking. And, if the question then is, if we spoke to a bunch of science advisors, if our research funders, if the big research funders were interviewing systematically science advisors, chief scientific advisors, and so on, would their results be that, I don't know, is it in fact impossible to codify or evaluate, these kind of impact case studies or these impact pathways and so on, whatever you call them? And if, impact is not linear, not about your own research, but about a body of research and so on, do we need to rethink the way that we define impact within academia? Do we need to rethink the way that that's connected to research funding and so on? Because, just to briefly say, one of the biggest discrepancies here is that in academia, obviously what matters is the outputs that you're working on, right? It's the research outputs that you're producing. But of course, as we just discussed earlier, in science advice, most of the time, the most impactful thing you can do is synthesis, it's collaboration. And how do we kind of bring those in, to these norms? It's not just citation of your paper, publishing in Nature, and then somehow some policymaker, makes a radical change to a legislation based on your Nature paper. That's not how it works, right? So it's a bit vague. I wish I could be a bit more precise, but essentially my point being that talking to these advisors, getting their inputs, getting their wisdom, I think can do a lot of good to how we manage science and fund it.
Lovely. Thank you very much indeed. You've been very generous with your time. For listeners who'd like to know more, you don't have to read the whole PhD, because Noam is a dab hand at communication, as you might have noticed from hearing him talk. And he's put together, among other things, a Twitter thread about his research and a bunch of funky diagrams, which I'll link to in the show notes for your further enjoyment if what you've heard has piqued your interest. Meanwhile, thank you very much indeed, Noam Obermeister, very nearly Dr. Obermeister, for joining me.
Thank you very much. It was great. It was really a joy.
The Science for Policy podcast is created by Tshaped. It's produced by me, Toby Wardman, with additional research and support from Agnieszka Pietrczuk. Tshaped is a consortium of Europe's academy networks representing more than 100 academies, young academies and learning societies from more than 40 countries across Europe. We're part of the European Commission's scientific advice mechanism, and as such we're funded by the European Union. Having said that, the opinions you hear on this podcast are those of the guests, and sometimes mine, but certainly not the views of the European Commission. This music is composed by Carlo Alfredo Piatti and performed by Elizaveta Sushchenko, and this last bit is particularly good.